Okay, class, in this lesson, we are going to learn to evaluate data distributions. So let's go ahead and get started. Okay, so in this example, we are going to find the measures of center and spread, okay? So we have a set of numbers, and you'll see it's 4, 12, 15, 9, 14, etc. And the question here is, what are the mean and standard deviation of the following data set? Well, first, let's go ahead and define what a mean or average is, and that is the mean or average in a data set is the sum. So we're going to add up all of the numbers or the values that are given to us in the data set, and you're going to divide that sum by the number of values in the data set. Okay, so in other words, in this data here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we got 16 data sets. So you're going to add up all of these numbers. You're going to take that sum and divide it by 16, and that becomes your mean or your average. Okay. Now, the standard deviation is a measure of how much the value in a data set vary or deviate from the mean. So it's actually the spread of the data, right? It's the measure of variability of that data. And to calculate standard deviation, there is a statistical formula to calculate standard deviation, but with technology, you don't need to have that formula. In fact, you could use a spreadsheet to calculate both the mean and the standard deviation. So for example, in Excel, you could type in the equal sign and then the word average, and then select the cells where the data is, and it'll automatically calculate the mean or the average of that data set. And then the same thing with standard deviation. You would type in the symbol equal and then standard deviation. In certain spreadsheets, it might be ST DEV, but you'll see the options show up when you type in certain letters or words, and it'll give you choices to select, and you're going to select standard deviation, select the cells that are involved, and it'll automatically calculate the standard deviation for you. Okay, so let's go ahead to example 2. Now, there is a different way to also calculate distribution of data, and that is the 5-number summary, okay? The 5-number summary includes the minimum value of the data set, the first quartile, the median, the third quartile, and the maximum value. My apologies for the misspelling here. That should be FIRST. In any case, so let's take a look at this data set with 3, 4, 4, 6, 6, 7, 9, 12. So whatever data set that you're given, you're going to arrange the numbers in ascending order, like this is, okay? And then the first thing we're going to do is identify both the minimum and the maximum value, okay? So once you have these numbers in ascending order, then it's easy to identify the minimum, which is the first value, and then the maximum value, which is the last value, okay? And then the next step is to calculate the median. Well, how do we do that? You're going to take the middle number of the data set, okay? So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay? So the middle values are going to be 8 and 9, so 8 and 9. When you have an even number of values, you're going to take the average of the middle two values, and that becomes your median. So in this case, we've got 12.5. If you have an odd number, then that's easy. You just take the middle term, okay? Then the next thing you're going to do is you're going to calculate the first and third quartile, okay? So the quartiles show how the data are distributed. So to find the first quartile, you're going to find the median of the lower half of the data, okay? So if we cut this data in half, which we've already done here, so we've got 1, 2, 3, 4, 5, 6, 7, 8, you're going to pick the middle term, okay? Since we have an even number of terms, we're going to pick the middle two and then take the average. So the first quartile here would be 6. And then for the third quartile, we're going to pick the two middle terms as well. This is also 8 different terms. So the middle two, we're going to take the average, and that's going to be 15.5. Okay, and then the next thing we're going to do is plot them, which is called a box and whisker plot. Okay, so what we're going to do is we're going to plot the minimum, which is here 3, the maximum, which is 25, and then the first quartile, which we calculated to be 5.5, and then the third quartile, which is 12.5. I'm sorry, the average or the mean was 12.5, and then the third quartile was 15.5. Okay, so we've got 1, 2, 3, 4, 5 points, and then we're going to box these in, the second and the fourth term, with a line through the third term. Okay, so what this is telling us is that we have an average or a median of 12.5 with a minimum of 3 and a maximum of 25. Okay, and with this box and whisker plot, what we see is that one of the quartiles, in this case the third quartile, is closer to the median than this quartile. Okay, when you have that scenario, it'll tell you how the data distribution is skewed. Okay, so I will cover that in just a minute, but this helps us to determine how the distribution is skewed. Okay, so let's go ahead and go on to example 2. So we're going to figure out how to use appropriate statistics to compare data sets. Okay, so how can you describe different types of distribution? Because distributions of data all look differently, but there are some general categories. Okay, so to compare the different types of distribution, what you're going to look at is the shape of the distribution. You're going to find the center and then the spread. Okay, the standard deviation, range, and the interquartile range are 3 different ways to measure the spread. Okay, so that's how wide or narrow the distribution is. And then the range of the data set is the difference between the maximum and minimum values. Okay, so those are the endpoints. And then, as we saw earlier in the example, the interquartile range is the difference between the third quartile and the first quartile. Okay, so that interquartile range is going to be from here to here. So the difference between the third quartile and the first quartile. So in other words, third quartile minus the first quartile, that gives you your interquartile range, or the IQR. Okay, when we're measuring center and spread, okay, there are 2 different categories. You're going to use the median and the interquartile range. Those go together. Or you're going to use the mean and standard deviation. Okay, when a distribution is skewed, a skewed distribution means that it has a shape that is stretched out in either the positive direction or the negative direction. So let's take a look at the pictures down here. Okay, so here in the middle, we have a symmetrical distribution. Okay, symmetrical because what's happening on one side is pretty much a mirror image on the other side. Okay, so it's and that's reflected across this mean. This dotted blue line is the mean. Okay, now when we have a skewed distribution, for example, this one right here, see how the median of this graph is greater than the mean. Okay, so when the median is greater than the mean, then what we have here is a skewed left. Okay, all the data is shifted mostly on the right, so that means the data is skewed in the negative or in the left direction. And then on the other side here, when the median is less than the mean, okay, that means that most of the data is over here, which means we call this a skewed right, or skewed in the positive direction. Okay, so what we are seeing is that the shape of a distribution can affect the measure of center and spread and determine which measure of center and spread best describes this data. The mean, median, mode are all about the same in a symmetric distribution, right? So mean is the average, median is the middle term, and then the mode is the term that happens the most. And in a symmetric distribution, they're all pretty much the same. And what we find is that you can use the mean and standard deviation to describe the center and spread as well. Okay, so when things are normally distributed, using the mean and standard deviation is the best way to describe what's going on with the data. When you have skewedness, then the median and the interquartile range, those pairs, or that pair is the best way to describe data distribution. Okay, so let's take a look at this example. Okay, so here's the question. What measures of center and spread would you use for the following data set? So we've got all of these numbers, and thankfully these are already in ascending order. And what we do first here is just kind of use a histogram. So this is like a vertical bar chart to show what this data looks like, okay? And what you could see is that the mean here is more affected than the median by this data distribution, meaning that this is skewed, right? So when this is skewed, it means that the mean is going to be less than the median, because the mean is going to be somewhere over here, and then the mean is going to be somewhere over here, and then the median is going to be somewhere over here. Let me say that again. The median's probably somewhere right around here, and the mean is somewhere in here, and then the median is going to be more to the right. So what we are finding in just looking at the picture, because this is skewed left, right? It's skewed negative. The median is going to be larger than the mean, okay? And when we analyze this and put this in numerical order and calculate the first quartile, the median, and third quartile, okay, what we find is that the range, we take the maximum value and subtract the minimum value to find our actual range. And then the interquartile range will be subtracting the third quartile, which is the middle term of the upper half, minus the middle term of the lower half. Okay, so 33 minus 21 gives us 12. So that gives us our interquartile range. Okay, so let's go on to our last example, and this is recognizing a normal distribution. Okay, so this requires understanding a little bit about how data behaves. And so what we wanted to do is to find whether the following variables will likely have a normal distribution or not. Okay, so let's take a look at example 1. The heights of all people in a large group. Okay, so if you got a large sample size, let's say the population of the country of the United States, and if you were to identify the height of every individual and plot them, okay, what we would find is that that graph would look like a normal distribution, okay? We would have an average somewhere over here, average height, let's just say 5 feet 9 inches, okay? And then you would have roughly the same number of people with height below 5 feet 9 inches versus the same number of people that are taller than 5 feet 9 inches. Okay, so we would say that this is normally distributed. Okay, so if we were to go on to part B, the probability of landing on each of 8 equal parts of a spinner. Okay, well, this is more of a probability, and the number of spins will determine the distribution, but if you were to do it enough, what we would see is that the distribution would look something like this. Okay, so if we got 8 equal parts, so this would be part 1, part 2, part 3, part 4. Let's continue this. Part 5, part 6, part 7, and part 8. All right, and let's say this is my frequency, and let's just say we did this 100 times, 200 times, 300 times, 400 times. So you might land on 1, maybe somewhere over here. Okay, 300 plus. And then on 2, you might land somewhere over here, a little bit over 300. And then on 3, maybe right around 300. Okay, and then 4, you might have closer to 400. And then landing on 5, maybe around 350. And then at 6, maybe at 375 or 380. And then on 7, maybe it's like 300. And then at 8, might be at 325 or 330, okay? So as you can see, the distribution is fairly level, okay? I mean, there are some variations, but if you did this enough, let's say we did it like 4 million times, for example, then these would all be pretty much straight across, okay? So the distribution is not a normal distribution, and it's not skewed either left or right. It's pretty level. Okay, now, part C. How about the scores, right? The scores on an easy test. So if you were taking a test, let's say it's 100 points, and you gave, or an easy test was given to a class, or let's say a bunch of classes, okay? We would find that the data, if we were to find their scores, or plot their scores, okay? So let's say this is 100, and this is 50, okay? We would find that most people would score in the upper range, right? So we would say that the median, so our median would be somewhere over here. This is our median. And our mean would be somewhere in about here, meaning that the mean is less than the median here, okay? And so when you have that, this means that it is going to be skewed left. Okay, so scores on an easy test. Now, the tests were a difficult test, then it would be the exact opposite, right? Most of the students would score somewhere down in here, very few would score high, and so you'd have the opposite scenario, and it would be skewed right, okay? All right, now the number of children in a family. Well, I think that it would be safe to say that most families have 0, 1, or 2 children, right? So let's say this is the number of children. 1, 2, 3, 4, 5, 6, 7, 8, and so forth. Okay, and let's say this is the number of families, and let's say this is in the United States. So we could say 50 million, 100 million, 150 million, 200 million households. And we'd find that most people have 1 or 2 children, 1 or 2, but as the number of children increases, we'd see a drop-off. Okay? So in this case, didn't really draw that correctly, but let's say in this case, most of this data would look something like this, okay? So in this case, we would say that the median is right about here, okay? So this is our median, and then our mean is somewhere in here. So in this case, mean is less than the median, or the median is greater than the mean, and so that means our data is distributed in the positive direction. We would say that this is skewed right. Okay? All right, so hopefully this made sense. If you need to go back to the beginning of the video to get some clarification, then please do so. All right, thank you.